Hello students. In this lecture again we continue with application of derivatives. We are going to deal with equations of tangent and normal itself like last lecture. Only thing is we are going to do miscellaneous exercise sums today. Now just to remind you all, look at the diagram and just refresh your memories as to what is a tangent and normal and what is the point of contact. If you remember last time, we had to find the equation of tangent and normal in the sums which were there. Now certain other points which I want to remind you all. First of all, if the tangent has slope m, then the normal has slope minus 1 upon m, because as you remember, normal and tangent are perpendicular to each other. Then the equation of the tangent, usually we write it in the form y minus y1 is equal to m into x minus x1. Similarly, equation of normal you can see for yourself. So this is what we are going to follow in this lecture as well. The only difference is we are going to solve miscellaneous exercise sums, which are also important from your exam point of view. Now these sums have been taken from different parts of your miscellaneous exercise. Some are MCQs, some may be true or false, and some may be solve the following. The first question, the second one of the MCQs it is. That is, the equation of tangent to the curve x square plus y square is equal to 5. And they have given that the tangent is parallel to the line 2x minus y plus 1 is equal to 0. We have to find the equation of tangent to the curve and we have to choose an option from here. So, from the equation of the curve, that is x square plus y square is equal to 5. What is the next step here? Yes, we differentiate the equation. Suppose you are confused as to what is to be done, please go through the previous lecture. Everything has been explained right from the basics over there. So, upon differentiating, it's an implicit function, so we differentiate like so. And thus finally we get dy by dx as minus x upon y. Now, in the next step, the slope of the given line, that is 2x minus y plus 1 is equal to 0, is 2. I hope you remember how to find the slope of a line. Suppose the general equation of the line is ax plus by plus c is equal to 0. Then the slope is minus a upon b. So over here the slope is actually minus 2 upon minus 1. So thus it comes out to be 2. Then the slope of the tangent. Now they have given that the tangent is parallel to the line. So parallel lines have equal slopes if you remember. So slope of the tangent as well is 2. Now we know that the slope of the tangent is 2. So we have minus x upon y as 2, because dy by dx, if you remember, that is nothing but the slope of the tangent at a particular point that is there. So minus x upon y is equal to 2 and minus x is equal to 2y. So from here we get x as minus 2y. See, that is the first part of the sum. Then putting x is equal to minus 2y in x square plus y square is equal to 5, we get the value of y like so. That is, y comes out to be either plus or minus 1. You can observe the steps for yourself. Now we have two options. Two answers for x we can get. Either x will be minus 2 or x will be 2. If y is 1, then x is minus 2. If y is minus 1, then x is 2. So in this way we get two answers for x. Thus when x is minus 2 and y is 1, we get the equation of the tangent using the formula y minus y1 is equal to mx minus x1. M is also 2 if you remember the slope of the tangent. So we get the equation like so. Solving it, we get the answer for the equation of the tangent when x is minus 2 and y is 1. Now when x is 2 and y is minus 1, again we solve it, we put it in the equation of tangent, and thus we get the equation of tangent like so. So both of these are equations of the tangent, and comparing our options which are given in the beginning of the question, we realize that A is the correct answer. The next question is a question which has come from true or false. That is, state whether the following is true or false. The question is, x plus 10y plus 21 is equal to 0 is the equation of normal to the curve y is equal to 3x square plus 4x minus 5 at the point 1, 2. So let us see what to do over here, whether to find it is true or false. So from the curve y is equal to 3x square plus 4x minus 5, we differentiate it and get the answer as 6x plus 4. Now dy by dx at the point 1, 2. What do we do here? We put x as 1 in the equation. So we get 6 into 1 plus 4, that is 10. So 10 is the slope of the tangent at that particular point. If 10 is the slope of the tangent, then slope of the normal is the negative reciprocal of it, that is minus 10. Thus the equation of the normal at 1, 2, we use the formula y minus y1 is equal to m into x minus x1 and thus get this cross multiplying and solving further. Now in the question they have given the equation of x plus 10y plus 21 is equal to 0. So obviously the given statement is false. Now we go on to question number 4 of your miscellaneous exercise. That is, solve the following. The first sum in that, find the equation of tangent and normal to the given curves. The first curve is xy is equal to c square at the point ct, c upon t, where t is the parameter. Now you need to listen carefully and understand this sum properly. So the given curve is xy is equal to c square. We observe that on the LHS is the product of x and y. So while differentiating we use the product rule. So we get x dy by dx plus y is equal to 0 because c is a constant and therefore RHS comes out as 0. Simplifying further, dy by dx comes out to be minus y upon x. Now dy by dx at ct, c upon t, that is given as a point of contact, isn't it? So we put x as ct and y as c upon t in the fraction minus y upon x. Thus we get like so, that is minus c upon t upon ct. So minus c upon t comes in the denominator here and therefore minus c upon t into ct, which is minus 1 upon t square. So dy by dx is minus 1 upon t square. We realize that dy by dx at the given point is nothing but the slope of the tangent. So slope of the tangent is minus 1 upon t square. Therefore, the equation of the tangent, now we know the slope of the tangent, we also know the point of contact. So the equation of the tangent comes out like so, that is y minus c upon t, because the point y1 is nothing but c upon t. So y minus c upon t is equal to slope, that is minus 1 upon t square into x minus ct. Ct is the coordinate x1 that is there. So I hope you understood this point over here. Similarly, when we know the slope of the tangent, we can find the slope of the normal. So slope of the normal is t square and therefore the equation of the normal using the same formula, we get it like so. If you want, you can pause the video and notice the sum, observe the steps properly. The second sum is y is equal to x square plus 4x. We have to find the equation of the tangent at the point whose ordinate is minus 3. Let us see how it is done. Now, from the curve y is equal to x square plus 4x, we differentiate this curve and get dy by dx is equal to 2x plus 4. That is simple enough. Then, what is the meaning of ordinate? Ordinate is nothing but the y coordinate. So here we have y is equal to minus 3. So y, that is minus 3, is the y coordinate of the point of contact. We put y is equal to minus 3 in the curve, that is y is equal to x square plus 4x. Thus we get x square plus 4x plus 3 is equal to 0, that is a quadratic equation. Solving this quadratic equation, we get x is equal to minus 1 or x is equal to minus 3. So the point of contact will be either minus 1 minus 3 or minus 3 minus 3. Now we consider first minus 1 minus 3. Now here dy by dx, if you remember, dy by dx is 2x plus 4. So dy by dx at minus 1 minus 3 becomes 2 into minus 1 plus 4, that is 2. So this is the slope of the tangent at that particular point. So then we can find the equation of the tangent by using the usual formula that is there. Thus here we get the equation of tangent. Now again for the normal, slope of the normal becomes minus 1 upon 2. And therefore the equation of the normal at the given point. So we get the equation of the normal like so. And thus we found the equation of tangent and normal at that particular point. Now for minus 3, dy by dx at minus 3, putting x is equal to minus 3 in the equation, we get it as minus 2. So this is the slope of the tangent at that particular point. Now the equation of the tangent we get by applying the formula. Then the slope of the normal becomes 1 upon 2, and therefore the equation of the normal also we get in the same way. Thus we solve the sum. So the third sum, x is equal to 1 upon t and y is equal to t minus 1 upon t is given at t is equal to 2. Does it remind you of something? Yes, it should remind you of a parametric function. So both x and y are parametric functions here where t is a parameter. So first we find dy by dt by differentiating with respect to t. So we get 1, that is t becomes 1, and minus 1 upon t becomes plus 1 upon t square. On cross multiplying we get t square plus 1 upon t square. Similarly, from x is equal to 1 upon t, we get dx by dt as minus 1 upon t square. Now dy by dx is dy by dt upon dx upon dt. Thus we divide both the fractions. The common denominator is cancelled. And so we get the final answer is minus t square plus 1. Now from here how to find the slope? Because we need the slope to find the equation, isn't it? So we put t is equal to 2 in dy by dx. So dy by dx when t is equal to 2 turns out to be minus 5 as you can see. Then, so slope of the tangent is minus 5 at that particular point of contact. Now still we don't know the point of contact. Let us see how to do further. Now t is equal to 2 and therefore x becomes 1 upon 2. From the question x is 1 upon t. So x becomes 1 upon 2. What about y? Y is actually t minus 1 upon t. So y becomes 2 minus 1 upon 2. Cross multiplying etc. We get 3 upon 2. So thus we get the point of contact as 1 upon 2 and 3 upon 2. So now that we know the slope and the point of contact, we can find the equation of tangent in the usual manner by doing y minus y1 is equal to m x minus x1. So solving it further, we get the equation of tangent like so. You can observe the steps properly. Then slope of the normal at the same point of contact is 1 upon 5. Why so? Because the slope of the tangent is minus 5. Thus we get the equation of the normal by applying the formula like this. And that completes the sum. Now in the next sum, y is equal to x cube minus x square minus 1 at the point whose abscissa is minus 2. Now what is abscissa? Abscissa is the other name for x coordinate. So remember, ordinate means y coordinate and abscissa means x coordinate. So here x is equal to minus 2. And putting x is equal to minus 2 in the given equation of the curve, we get y is equal to minus 2 cube minus minus 2 square minus 1, which comes out as minus 13. Thus the point of contact is minus 2 and minus 13. Now we have to find the slope as well, isn't it? So from the equation of the curve, differentiating the equation, we get dy by dx as 3x square minus 2x and dy by dx at the point of contact, that is at minus 2 minus 13, comes out by substitution, it comes out as 16. So slope of the tangent at minus 2 minus 13 is 16. Now once you know the slope and the point of contact of the tangent, you can easily find out the equation of the tangent by yourselves. Similarly, you can also find the slope of the normal and the equation of the normal. So this sum you are going to complete as an assignment in your notebook. Needless to say, the other sums which I have solved today in miscellaneous exercise, those sums are also expected to be written in the notebook. Remember, the more you write, the better your practice becomes. the more faster you become at solving the sums. So with this we complete the lecture. In the next lecture, we begin with the next concept of the lesson. Till then, stay safe and healthy.